Mr. Minnick, helping my students trace while loops. On this worksheet, while loops are being used in a more meaningful way than a previous worksheet. They're being used in an indefinite or indeterminate situation where we don't know when the customer is going to be finished shopping, perhaps at our store. But we will tell the customer, please type in -1 to signify that you want to quit this online transaction here at Amazon.com or whatever. So look at the numbers in exercise 1 that we're all agreeing that the customer is going to input. 3, 4, 2, and then eventually he or she types in a -1. That -1, because I typed it out in my prompt here, it's called the sentinel value. It's the agreed upon number, Tim, that the customer knows to type in when they're finished. Say uncle if you want me to stop twisting your arm. Uncle would be the sentinel value. Okay, let's go. Sum equals 0, num equals 0. They've already been recorded there, so that's good. Now we hit the while loop. Control expression. Tim, what does the exclamation mark equal symbol do in Python? We haven't studied that for a while. It means not equal to. So true or false, num, which is currently 0, not equal to -1. That's a true. That's true. So we do go through the loop in exercise 1 at least once. Okay, the right-hand side, sum plus num, that's boring, 0 plus 0. So we're taking a 0 and we're right to left. We're putting it into the variable sum. I know it already says 0 here, but I like my students to carefully cross out that 0 and put another 0 under it to reflect the fact that you know a 0 overwrote a 0. If you don't do careful little things like this, computers can't just think things ahead like a human can. I like to show what the computer thinks, and the computer does overwrite a 0 with a 0. Moving on. Now let's unravel this input function here on this worksheet for the first time. Python brings up like a blinking cursor or something. The person, we're agreeing to the fact that they input a 3. So a 3 gets inputted into the computer because of this input function. But really, the computer treats it as a 3 in double quotes, because that's just the way the input function works. And if we want to store the 3 in this variable that was previously used to store the integer 0, we have to, as the coder, we have to know to rip these quotes off. So it's like taking the saran wrap off of a cookie that you just bought at the school store. You gotta take that off before you eat it. So the int function does that. It intifies it, as I like to say. So that 3, the number 3, Tim, gets plugged into the variable num. So we cross out that 0 and make it a 3. That was a pain in the butt to understand that, but that's it. 3 got put in there for num. We loop around to the top of the loop. We check the control expression to see if it's true or false. 3 not equal to -1. Oh, that's true. 3 is not equal to -1. That's true. So we go through the loop again. We add the right-hand side up. Sum plus num. Oh, interesting. 0 plus 3. It's 3 overall. So the 3 plugs into sum right to left. So cross that little 0 out there and make it a 3. We execute the line of code next. We just agree that a 4 is now inputted to this computer program. So a 4, the quotes get ripped off of and all that jazz. So a 4 plugs in there for num. We loop back up to the top. We check the control expression, which is still true. So we go around again. Sum equals sum plus num. 3 plus 4 is 7. 7 plugs into the variable sum here. So cross this 3 out and make it a 7. And then the next number that gets inputted by the user is a 2. So it plugs in for a num here. Carefully going slowly so I don't mess up. We loop back up to the top. 2 not equal to -1. That's a true fact. So we go through the loop again. This is fun. Sum plus equals num. 7 plus 2 is 9. The 9 plugs into sum. So cross that 7 out, make it a 9. We hit the next line of code, and the user types in a -1. The quotes get ripped off of that -1. The -1 gets stored in the variable num. We loop back up to the top. You can see this coming now, right? The not equal to symbol is interesting here because you're asking the question, is -1 not equal to -1? It's like a double negative or something. Anyway, it's false. And because it's false, you go straight to jail. You don't collect $200 in Monopoly. You don't go through this loop. You just finish the... Oh, look, we have another line of code that's interesting here. It's not indented. So I need you to execute that line of code on this worksheet here. So let's unravel that. I'll circle these numbers here a while because they are the final values of that from that loop. Print, let's work from inside out. STR sum. Now sum is the plain number 9. The str function, you'll remember from earlier study, puts quotes onto a number. It turns an int into a string, also known as text. So that's interesting. We now have a 9 with double quotes around it. Then we have this concatenation operator that's gluing the 9 with a blank space. And that's being concatenated with str of num, which is -1 with double quotes around it. So your output is a 9 with a space and a -1. Now sometimes I like you to put quotes around all this to show me that the whole thing is thought of as a string. I didn't tell you to do that in the instructions, so I will not do it here. But there are some worksheets where I'd like you to show me that you know the final answer was considered text. 9 with a little gap representing a space and a -1. Look at the other exercises without doing them. In number 2, it's the same code as number 1, only I switched the order of the two body statements in the while loop. It might cause a different answer. Good luck with that. Oh, by the way, in number 1, did you see that the whole purpose of the code segment in number 1 is to add up the numbers 3 plus 4 plus 2, but not to include the -1, which was just being used as a sentinel value. It could have been -2 or -3 as long as the coder communicated that to the customer. Number 3, interesting. It's pretty much the same, but the idiot customer types in a -99, probably meaning to quit the program, but they didn't type in -1, and that may or may not cause the while loop to terminate and exit. I don't know. Trace it carefully. I tell you, trace it carefully here. And maybe the -99 gets added into the running total. Maybe it doesn't. That's for you to figure out and me to check with my answer key tomorrow. And number 4, another variation that you'll see on the AP exam and sometimes in life, because not every bank is probably perfect. Here, instead of num not equal to -1, we have the safer control expression num greater than or equal to 0. It's just my preferred way of coding something like this rather than relying on -1 as a sentinel value. But then I threw in a 999 there, so trace that carefully and show me what the output is eventually. And finally in number 5, which I can't really show you here in the video, you have an AND in there, so you have a compound control expression. You have a compound control expression where it is, you remember truth tables and asparagus and broccoli, and they both have to be true or false or something? Well, just like complicated if statements, you only go through the while loop if all of that is true. And it hinges on sum as well as num in that interesting problem with a different set of numbers being typed in. Okay, that's it. Have a good time doing the worksheet, and I look forward to checking it tomorrow.